Today, we're going to be learning about combinations and permutations, also known as combinatorics. In English, we use the word combination loosely, without thinking if the order of things matter. In other words, my M&Ms are a combination of red, blue, orange, yellow, and brown. We don't care what order the M&Ms were placed in the bag. We could also say the combination to the safe was 472. Now we do care about the order. 724 would not work, nor 247. It has to be exactly 472. So in mathematics, we use more precise language. If the order doesn't matter, it is a combination. If the order matters, it's a permutation. So really, this lock and the locks like on your lockers should be called a permutation lock, not a combination lock. For permutations, there's two types we're going to be looking at. The first is called a repeating permutation, and we just multiply all the possibilities. So, in the block above, this lock on each thing, as we can see, goes from 0 to 9. So there's 10 options on each column. So we have 10 different numbers we could use for the first number, 10 different numbers we could use for the second number, 10 different for the third. So there are 1,000 possibilities. Similar to this, how many outfits can you find to make from 6 shirts, 2 pairs of pants, and 3 pairs of shoes? Again, we just need to multiply all the possibilities. So 6 shirts times 2 pairs of pants times 3 pairs of shoes, because we would need one of each of those, gives us 36 possible outfits. The second type is non-repeating. And for this, we're going to go to Desmos. You're going to click on your keyboard. You're going to go to Functions. You're going to go to the Stats tab. And we're going to select where it says NPR. P standing for permutation. So what if the numbers on the lock can't be repeated? We have 10 numbers. We want a permutation of 3 of them. So I'm going to go to Desmos. I'm going to click on my keyboard. I'm going to click on Functions. I'm going to go to the Stats tab and NPR. And the parentheses are going to pop up. So in this situation, NPR, the original number of possibilities, our 10, comes first, and then comma, the number we want to select, which is 3. So there are 720 possibilities. For combinations, we are just going to worry about when they are non-repeating. And again, we're going to go to Desmos. We're going to go to the keyboard. We're going to the Functions button. Then to the Stats tab. but this time we're going to choose NCR. So, from a student body of 230 students, how many different committees of 4 students are possible? And the reason this is just a combination is because when you're on a committee, it's just a group of people. There aren't any different ranks for them. So we're going to do NCR. There's 230 students total, and we're choosing from 4, or we're choosing 4 of them. So functions, it's on my stats tab. NCR, 230 students, and we're selecting 4 of them. So there's 113,582,855 possible groups we could make from that. All right, here's some for you to try. I want you to pause your video and determine for each of these situations, is it a permutation or a combination? Pause your video and take a minute to do this. All right, let's see how you did. How many ways are there to pick 5 teachers from a staff of 110? There's no ranking to these teachers, so this would just be a combination. We're just making a group. How many ways are there to distribute 9 different books among 15 students if no student gets more than 1 book? Since the books are different, the order that we hand them out is going to matter because that means different kids are getting different books. So this is a permutation. How many ways are there to pick a group of 4 different letters from the 26-letter alphabet? Since it's just a group and not a word, this is a combination. How many ways are there that we can, how many ways can the 3 offices of chairman, vice chairman, and secretary be filled from a club of 25 members? Since we have these 3 different ranks, the order we choose them is going to matter because each one time we choose it would be a different rank, so this is a permutation. So for the first one, we would be doing NCR. We have 110 staff members, and we're choosing 5. For this permutation, we have 15 students. We're doing permutation, we have 15 students, and we're doing 9 different books. For NCR here, we have 26 letters, and we're choosing groups of 4 of them. Here we have 25 members, and we're choosing 3 ranks. Now, for 1, 2, and 3, those are easy. You guys can go ahead and type them in Desmos, and you should get the first one, 122,391,522. For number 3, you should get 14,950. And for 4, you should get 13,800. For number 2, when you put it in Desmos, it's going to give you a weird answer. So let me show you. So this is NPR 15, 9. So because this is a large number, it puts it in scientific notation. And I'm going to show you how to take it out of scientific notation. So I'm going to write this number down, but I'm not going to write the decimal. So 18, 16, 21, 44. Okay. Since it's times 10 to the 9th power, I am going to take the decimal point and I'm going to move it 9 times to the right. So it was here. 1, 2, 3, 4, 5, 6, 7, 8, 9. these two blank spaces, I'm going to put zeros in. So our actual answer is 1,816,214,400. That's all for today. Fill in your summary and we'll see you in class.